So I'm going to talk about Scotiabank, or how we think about the bar for PII in cloud and how that relates to on-prem. I'll talk about just some basic protections that everyone does for applications in cloud and our principles for PII, because our position is that you do the things to lock down your application, but that's not sufficient for PII at scale for analytics. Talk a bit about the principles that we're applying and let you know what we're doing. So Scotiabank's been around for almost 200 years, and so we have about 100,000 employees, about 10,000 in IT, and we're the third biggest bank in Canada, and it's Canada's most international bank, so we're in the top 3 in a bunch of Latin American countries and the Caribbean. So we have a pretty heterogeneous environment. We had at one point 69 data centers because we'd acquired 30 banks, each with 2, and sort of going through consolidating that, and we're moving a lot of stuff to cloud. So the latest initiative has been to move the data to GCP, and we're in the middle of that journey. So our assertion that it needs to be safer for a bunch of different reasons. So on-prem, if you went to get data, I think this applies to many enterprises, and you want to get data out of existing legacy systems, it's hard to find because there's no good way to locate the data. And then it's going to be spread across a whole huge number of different systems in different places, in different formats, and you've got inconsistent performance and all that. Whereas in cloud, when we ingest it into cloud, we're transforming it into a standard schema, and we have a canonical representation of what a customer is, and we have data discovery tools, and it's all high-performance storage on high-performance network, all in one place, all wrapped up with a bow on it for you. So if you do find a hole, it's going to go a big blast radius, and that's going to happen fast. So for that reason, you can't just do what you do on-prem. You need to proportionally improve the security posture. And we think that the move to cloud is also a forcing function, because what happens is if you try and transform the bank and you just start going around to teams and say, okay, you need to think about it differently, and now let's refactor all the databases and try and refactor 1,000 production databases in place, you'll never get anywhere. But it's an opportunity just to rethink what we're doing for the security posture, and then say these are the rules in the new world. So if you want to bring in data, then it needs to be in the canonical format, in a standard schema, and we track lineage, so you know exactly how the provenance of each data item and all that, and that's the rules of the new world. So we're using it to just up the game across the organization. So I'm going to talk for a minute about just kind of the basics about what everybody does to lock down an application. So first of all, you want to do the authentication, and that's about who it is that's connecting. So for that's our customers, that's tellers in the branch or other people working for the bank, or for fintechs and open banking and trusted partners, that kind of thing. So there can be different types of users. And then we have a system where we authenticate more strongly dependent on the risk. So a customer's coming in, yes, you need to tell this is really a customer, and if they're checking the balance, you can make that fairly lightweight, so it's not as intrusive, but if they're going to take a lot of money, transfer a lot of money out of their account, you need to make sure it ups the game. You really have to make sure it's actually them. So, sort of tied to the risk, we would use multi-factor authentication and step that up. So of course, you want to figure out if people are really who they think they are, who they claim to be. And then you want to authorize it. So the authorization is just about what those users are allowed to do. So the users would connect at the edge of cloud, so that they would be coming in and they would hit an application in cloud, and that's where we would authenticate them. We would know what they're allowed to do. Within cloud, the different cloud services would connect with a service account. So we pass the identity around for entitlements to data and so forth within that, but the actual services bind with the service accounts. And then you want to manage the accounts carefully. So if you've got the access control list, you need to audit those and make sure people are really still in that role and they have a legitimate need to see that, to see the data. And also just manage carefully the privileged accounts, all that kind of stuff. For networking, we're assuming that, yes, even though you're not authorized, if you're not authorized to hit a system, then you shouldn't be able to reach it either, just as, typical defense in depth stuff. Encrypting at rest and in flight, sure, yes, everyone should do that, and it's good that cloud does it. I don't think the attack vector is actually somebody breaks into a data center and runs off with a drive, and then, so it's more, and I don't think it's sufficient to just have transparent encryption that you're able to just easily decrypt. So I'll talk more about encryption. And then just a bunch of hygiene stuff about, keep your patching up to date and harden images, all that kind of stuff. So that's just all the basics about how you lock down an application, which is I'm sure, all the basic stuff that everybody knows. Then there's the next layer would be infrastructure as code and disallowing interactive edits to it and have, approvals for pull requests and more scrutiny for sensitive ones. If it's got, changing a firewall rule, you'd want to get approvals from security as well as other people, all that kind of stuff. And then that, to just reduce the risk of either accidental changes or malicious insider changes. And then I think the bank's done a good job of articulating the security control objectives. There's a good list of hundreds of controls that need to be enforced. And then, we build infrastructure pieces. We run the tests for, is it compliant with all those controls? So, and then the first bar that we implemented was just that applications can be made safe. So we just make sure the platform, if you use the platform properly, then you can make the application safe, and then you can demonstrate it is safe with a bunch of tests, and that was the bar. The next bar that we're enforcing now is that using the platform, anything you're building on Plato, you can't do anything unsafe. And then that lowers the bar for what you need to do as far as scrutiny and getting approvals for launch and all that kind of stuff. So is the bar we're enforcing. So that gives you pretty safe applications, I think. And I think that the change control should probably keep them safe. But that's about locking down the application and not really about so much the data at scale. And I think that it's insufficient for PII, for analytics. So we've established some principles that we apply to PII. So the first thing is that we tokenize when it comes in. So by tokenizing, I just mean that we encrypt each item of data as it comes in. So instead of just encrypting the data set and then transparently decrypting it when you see it, as it comes in, each individual item you would tokenize. So we would encrypt it, replace it with a ciphertext and some tags to know what key was used and so forth. So you can look at one of the tokens, and then you can tell looking at it, it is a token and what key to use to decrypt it and all that. So it's an object that you can manipulate. So we tokenize on the way in. Another thing is that we want to make reidentification rare, because actually you can do a lot of common operations you can actually just do on the tokens. So if you're doing machine learning and you're training a model to look for credit card fraud, you would look at, what the size of the transactions and the pattern, the timing, the, geographical location, all that kind of stuff. All those are good signals for training the model. You're never training it on, it starts with the credit card number starts with the digit 4 or something. That's not a useful signal. So you can do it just on the tokens. I'll talk more about the re-identification. And then for this approach of governing the intention instead of managing the artifacts, I'll talk more about what I mean for that. So the tokenization, as I said, we're encrypting each piece of data as it comes in. So the credit card number comes in, it's 123, it turns into a token ABC, which is actually a big, long, opaque string that's meaningless. But it's globally consistent and unchanging, so you've got referential integrity. So you replace the credit card number with a token that will always be the same, and if you're bringing it in from 10 different back-end systems, and you bring it in today and in a year, and if you notice a credit card number in some unstructured text, it'll all be replaced by the same token. So you have joinability in the data sets. You just can't see what the content of the original PII was. So we tokenize it during the ingestion. We do the transformation to standardize it into the canonical format and so forth, the standard schema when it comes in. And we do that, we're using Cloud PubSub and Dataflow and DLP to do the encryption. And we're pretty happy. I think it's pretty moderate costs. It's less than about 5 milliseconds to do the encrypt or decrypt. And for 100-byte strings, it's about 3 cents per million records. So not too bad cost-wise, cost in performance or money. And so now you have the opaque tokens, and so and then they can flow freely around the system. So you've got the tokens, applications can just read them and manipulate, pass them around, copy them. All that is all pretty low risk. And we do, in fact, enforce RBAC rules for what data you're allowed to reach, but it's just less sensitive just because it's not valuable information. And as I said, yeah, so that we can do a lot of the training against it on the tokens. So that goes back to this being a rare operation to re-identify. So this idea about governing the intent instead of the artifacts. So in the example, let's look at for zero trust networking. The reason that zero trust networking is nice, you just make the direct connection between the two ends, and you just don't trust anything in between, so you just use mutual TLS. So in that, you just go, okay, this service A can talk to service B, you need to lock that down, and then, which is nice and straightforward, you can then remove that. Whereas if you look at the artifacts instead, that the artifacts that you create. So if you do it with these two services need to talk to each other, and to implement that, you open up ports in firewall rules across 10 different firewalls, and then you make that work, and then you do that for 10,000 systems, and then now you have a bunch of rules, and then you say, okay, these two don't need to talk to each other again. You'll never actually fix the rules because nobody knows how to remove the rule without breaking everything. So it just sort of is, it's just hard. When you know the intent was these two should talk to each other, that's easier to manage. But if you're trying to manage the artifacts, there's just so much noise, it's a lot more complex, the signal gets weakened, and it's harder to deal with. So that idea from zero trust networking, which we're applying to zero trust PII reidentification. So we're managing the intent we're managing it in the same way for zero trust PII, the same way as we would in zero trust networking. So I'll just walk through a little use case to illustrate what I'm talking about. So you have an application ABC that you want to, so it's say a teller application in the branch. The teller's using it, and then okay, they need to look up a customer record, the customer's standing in front of them. So you want to get 20 items of PII. So that use case, you're about to click the button, it's reasonable to get 20 pieces of PII re-identified in the next 10 seconds. So so then now you want to do that in this zero trust environment to be able to achieve that. So I'll walk through kind of what the pattern is. So what you would do is, and this would all be hidden in libraries, it should be transparent to the application development. So you would ask a PII manager, which is part of Plato. So in this, the first application ABC is a cloud application, but outside Plato, built on Plato, but not part of Plato. Everything below is Plato. So you would ask the PII manager, and you would register the intent and say, okay, I'm going to click this button. I need to get this many records of PII in this time. So the PII manager looks and goes, yeah, that's a legit use case. This application is allowed to see Canadian data, and it's allowed to see up to 1,000 items at a time, so this is within that. So then it would grant a certificate that the application can then use to delegate its authority to re-identify. So now when it makes the call, it makes the call to the API saying, okay, I'm making this call, and if anybody needs it, here's the authority to re-identify 20 pieces of PII in the next 10 seconds. So that gets passed down. So then the API goes and it fetches the storage. It'll hit spanner and it'll be all tokenized data. So it could either be, you're looking for what are all the transactions associated with this customer, or if you're doing a query against tokens, then you would say, I want to look for all the transactions for credit card 123. It would look up the token for that and it'll go ABC, so it does a query for what are all the transactions for token ABC. So you get the set back. And then, so you would get a bunch of, so now that query returns, so now XYZ has a bunch of tokens in hand that it wants to re-identify. So as this certificate passes down through the stack, then each system that sees it will sign it. So ABC said, okay, I'm going to make this call. I want it, and I'm just passing it into the system now. XYZ sees it and goes, okay, I've seen this. I've seen this certificate pass by, and I sign. I've now seen it. It looks good to me. It can constrain the permissions if it would like, or just pass them on and sign it. So the application passes in the certificate and its public key for encrypting the data back. So now you want to re-identify. So now it calls the re-identification service with the signed certificate that it's signed saying, okay, it came from ABC, it's now passed through XYZ, and here's ABC's key, and it calls the re-identification service. So now the re-identification service calls the PII manager and says, okay, is this certificate legit? Is this really, did you issue it? Was it really on the whitelist? Yes, it looks good. That's the right key, all that. And then it just it keeps a tally of how many pieces of PII were re-identified in that certificate. A bunch of this can be kind of parallelized and so forth. It's not really a performance problem. And then it goes, okay, that looks legit. So it calls DLP and gives it the token, reverses that back, and gets the PII. So now the re-identification service has the PII in hand. So what it does now is it takes that clear PII and it encrypts it with ABC's key. So briefly in memory, there was the token. It passed the token down to DLP. It comes back with clear text in TLS, but clear text, and then that'll encrypt that, so it's now ciphertext. And now the ciphertext gets returned to XYZ. So XYZ returns it back to the application. The application uses its key to decrypt it, so it gets the payload. It gets the piece of PII. So there's a couple of nice properties of the system. So one is that we assume that the security will be defeated, and somebody's going to, because if somebody gets in, the attack is going to be, they're going to get in and somebody's going to run arbitrary code somewhere in the system. So here, if you do hack in, all you see anywhere in it, if you're just passively sitting in XYZ, or then all you'll see is some tokens will pass by, and then you'll see some ciphertext pass by, but you don't actually see any PII. And because it's encrypted, it's either tokens or ciphertext, so it's encrypted at rest, it's encrypted in flight, it's also encrypted in memory, so you never actually see the PII in the clear. So if you hack in and you get into XYZ, it does you no good, you don't see any PII. And then, and if you're actively trying to attack something, you can hit the storage and you can read some tokens, but you can't re-identify. You can call the re-identification service, and it won't do it for you because you don't have this signed certificate from ABC. And what you actually need is you would need that, and even if you hack so you hack into the re-identification service, so now you have the power to re-identify, but you don't have access to tokens. So you can't, by hacking a single system, get the PII. So it's zero trust. The other nice property is that you get, as the certificate gets passed down the stack, you see that this one came from ABC, then it came through XYZ, and it was signed, then re-identified here. So you actually have the clear intention that ABC needed to re-identify this much data for this user at this time, and you have the call stack, the trace through the system for all the calls for that PII. So it makes it really easy in a machine learning context to just look at, instead of you've got a billion calls through some API or whatever, and you're trying to parse it out, you just have, this call for re-identifying PII took these 4 hops through the system. And then you see something that comes in from a side channel. You have whitelist for who's allowed to call the re-identification service. So it needs to come down through that path. If somebody calls not on that path, you can tell because it's obvious that they've defeated something. You can see what all the normal call paths are. So just because it's a lot cleaner signal, it's a lot easier to see anomalous bad behavior. And again, you can't get any PII and it's zero trust in the same way as zero trust for networking. So we're building this in GCP. We're really happy with the relationship with Google on this. Partly we picked them because the strength of the technology is foundational, performance, security, all that stuff. Partly we've got a good relationship with the engineering teams. They're helping us build stuff, and they're listening when we're putting in feature requests and being pretty responsive there and helping us get that delivered. So we're using DLP data flow on the ingestion. We're using it for the structured data. We're encrypting the structured data as it comes in, so we know in this record, this call, this field is a first name, this is a last name, so forth. So if we know that we know which fields are PII, then we tokenize those, and then we also use it to scan for unstructured data. So if the data's in, but it might contain some PII, then we'll scan it using DLP. And we'll find, and then it uses regular expressions and machine learning and so forth to identify the PII. And in that, you'll get the token. So if it sees a credit card number in there, it'll tokenize it in the log or the unstructured data or whatever, and then the same token would be assigned to that if it came in as structured data. So then you're seeing, okay, in the log, you see you can see in the token, you see it's a tokenized credit card number, and then you can look in there, and then and then you can go join it with structured data from everywhere else, and you can still reverse that. And if you need to, you can re-identify if you've got a need to do that. And then we're using Cloud KMS to manage the keys, which we did the crypto team at the bank did a whole assessment, came out happy with the whole way that all works. We're quite happy with that technology. So just to summarize that, kind of the way we think about the PII for analytics. So if you're coming in for a use case of just there's some PII that a single application needs to access, then you already have the zero trust. You've got an application and it calls a database. You can just encrypt in that database. It's a simple relationship. And then you can go, okay, so the data in the database is okay. It's only connected by a single application. You can lock down that application and you can understand the access pattern, make sure nobody else can hit the database, so it's a nice understandable pattern, so that's okay. Where we tokenize is where you have data that, like for analytics, where you have the data needs to be hit by many applications. So if you've got 1,000 applications reaching the same data, you can't be satisfied, you're secure as long as you lock down all 1,000 applications properly, which you'll never get right. So, which is why we need to not trust. So we authenticate, and we're really careful about that, but we assume that somebody will defeat it. And then we look at whether you're authorized to be hitting there, and we're really careful about that, but we assume that unauthorized access is going to happen. And then so we constrain the network, so you shouldn't be able to reach, these two systems aren't allowed to talk to each other. You shouldn't even be able to reach it. We assume, okay, they will find a way to reach it. Somebody will break something, an insider will open a hole, whatever. So all those, we just assume that those will be defeated. And then we have this rule that you can't have, that no single hack is going to get data. So if there is a hack, then you just need to detect that quickly. You can see anomalous calling patterns. If it's coming in on an unapproved path, you can notice quickly because the calls in the logs, the call is not going to be paired up with a legit call. It's going to pretend it was called from there. You can compare the two and flag that quickly. So there's lots of those scenarios you can catch from the logs and alert on that and shut things down. So we assume that hacks would happen, and we want to detect that quickly. And then we want to track the intent for the PII and not trust the rest of the system. So, and the important principle in that is that you track the intention to do the reidentification. So up front, you want to track that there was a legitimate need for this application to see some PII, and so you vet that. You do it against your list of what data is that application allowed to see, who would be allowed to see that, constrain the applications. You have this much data, the application is allowed to see this much, the user is allowed to see this much of that, so you scope that down and enforce that and then pass that through the systems, which gives you a nice clear signal about what was allowed for what time, track the whole flow through the system for how that goes to see, so you can detect that. And then just because you got a nice clear signal, it's easy to detect anomalous behavior. So you're going to be able to see, I didn't expect a call on this path. For every call, you have the path through the stack tied back to the delegated authority in the certificate. So the result of this is that no single hack of the cloud, the data platform on cloud, results in any data, and it's zero trust. So, and the reason you can't get anything by hacking a single system is everywhere except for, so the application has, anybody that proves they have a legitimate business need to see the PII are granted it. They're given the authority to delegate that through the stack so that the right things can happen. But everywhere else in the system, it's encrypted at rest, it's encrypted in flight, it's encrypted in memory, and malicious actors just never see it in the clear. So if it's never in the clear, there's not very much they can do. So that's the basic use case. I wanted to sort of run through that use case and leave some time for questions. While I'm here, so we're implementing this. I'm hoping to get some support from Google Cloud to be, it seems like something that could be supported in Anthos. I think that all this passing through the call, because it's the same mechanism basically as you want to be able to trace calls through the system, and you can do that in Istio, and the calls, and they do that by putting an identifier in there, and you can put payloads that will get called down into the tree, the call tree. So you should be able to do the same thing with the certificates, sign them. So I think native support could help with this. I'm requesting that this PII manager to to create these certificates and then sign them and govern it and put in the building blocks for zero trust PII management. I'm pitching that I would like them to build into Anthos. So having those conversations. And that's what I have to say. Any questions?